You don't want to be left out when others are earning good grades in circle theorem. Learn from this problem. Calculate the value of angle WYZ. And so the first thing you need to do is to identify the problem WYZ. So that's this angle here. It is marked WYZ. We have two circles here overlapping at this point, and then we have a triangle in this diagram. So the very first thing I could say here is O is the center of the circle, and so the entire line WM is a diameter. That's a diameter. And so based on the information I have here, I know somehow, somewhere in this diagram, we can have angle in a semicircle. You remember that theorem, angle in a semicircle. For you to talk about angles in a semicircle, you need to have a diameter. And so I have a diameter here. And so I'm just going to produce a line such that it makes some sense. I want to join line X to M. Good. And so I have an angle formed on X. There is an angle that is formed on X, and that angle there will be at 90 degrees. The reason is angles in a semicircle. So I would say angle WXM is 90 degrees, and the reason is angle in a semicircle. Okay, now I haven't done that. Because of that blue line, I now have a cyclic quadrilateral XMZY. XMZY is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whose vertices is on the circumference of the circle. So what I have there now is a cyclic quadrilateral because I just inserted a line there, a logical line there. All right. So let me remind you about the exterior angles of a cyclic quadrilateral. Permit me to draw a circle. So let's say this is a circle, and I have this as a cyclic quadrilateral. All right, this is a cyclic quadrilateral. When a line is extended, a side is extended, an angle is formed outside, and so this angle is called the exterior angle. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. A cyclic quadrilateral has four interior angles. You have 1, 2, 3, and 4. All of these are the interior angles. But the exterior angle is equal to the interior opposite angle. So the angle that is opposite to this exterior angle is this angle here. So this exterior angle is equal to the interior opposite angle. If I extend this line, for instance, I have an exterior angle formed. It is exterior outside. This exterior angle here will be equal to this interior opposite. Mark the word opposite. Not just interior angle, but interior opposite angle. Okay, so now I want to apply that idea in solving this problem. Now let's get back to this problem. Look at this angle here. This angle here. I've already told you that XMZY is a cyclic quadrilateral. So I want you to see that this line is extended, and so an exterior angle is formed outside here. This exterior angle here, E, will be equal to the interior opposite angle. So my attention is shifted from finding this angle to finding this exterior angle here. Though this exterior angle is part of the interior angle in this triangle WMX. So I want to find this exterior angle, because I know that this exterior angle will be equals to the main problem I want to solve. So let me call this exterior angle A, for instance. Let me call this A degrees. So I would say that A is equals to angle WYZ, and my reason is exterior angle of a cyclic quadrilateral. I hope this is clear to you. You can leave your comment in the comment section. Please follow for more videos, like and subscribe to my channel. So now let's find the value of A. We already said this is at 90 degrees, angles in a semicircle. So we'll say that 48 plus 90 plus A equals to 180 degrees. And the reason is sum of angles in a triangle. Sum of angles in a triangle. So when we add up all of these together, A will be equals to 180 minus 90 minus 48. I know someone would have just said 48. Someone would have just said 90 minus 48 because you already have this as 90. I know that's correct. So this is going to give us 42. So therefore, angle WYZ is equals to 42 degrees. And that's it. You get your full mark.